Okay, the first thing you have to be able to do when you're graphing rational functions is first recognize what a rational function is. A rational function is a function that has variables. Actually, you don't have to have variables in the numerator and denominator, but you do have to have numerator and denominator with variables and or just numbers. So like, for example, what I mean by that is like, look at question, if you look at your homework, number 23 doesn't necessarily have a variable in the numerator, but it has x plus 5. That's a rational function. Okay, that's a rational. These are all rational functions. So most of the time they have variables in the numerator and the denominator. Okay, so they as you increase, this is the back page, they get increasingly more difficult. Okay, so the first thing you need to know how to do is to find the domain. The domain is an old problem. The domain is all of the x values. What numbers can you plug in to do this? So in other words, what's the pool of numbers that we get to pick from to actually graph this? So what you're going to do, the sky's the limit, except for what two numbers?
3 and negative 3.
And how did you know 3 and negative 3?
Because you said
It's going to foil it? Or?
So you know, so there's something you already know. You know that you can't use 3 or negative 3. Why? What's the reason?
Because it would be 0 in the denominator.
There you go. That's the reason. Because if you were to use 3 or negative 3, you would get a 0 in the denominator. And 0 in the denominator of a fraction means it's undefined. So what is the pool of numbers? It's the entire universe of numbers except for three and negative 3. So how do you write that in interval notation? This is an old problem. We were tested on one of these before. So now, when we tested this question and I asked you what the domain is, we did it in interval notation. In previous years, we wrote x cannot be plus or minus 3. I don't know where you're going to be next year, but make sure that whatever math class you're in, you understand how they want you to write the domain. So just I'm showing you both ways. Sometimes they'll have you do it in set notation, x such that x cannot be plus or minus 3. So it could be any of those ways. Now, VA stands for vertical asymptote. We're going to start here. What is the vertical asymptote? It's an imaginary line that we will draw with a broken line. It is where the denominator is set equal to 0. So while we're at finding the domain, you set this equal to 0, and you say x equals 3 and negative 3. Now, what are these? These are lines that the graph cannot cross. Think of if you had a dog and you had an imaginary, one of those imaginary invisible fences. Your graph cannot cross these two lines. It'll get zapped, right? So graphs will not cross vertical asymptotes. A VA is a vertical asymptote. Let's try another one right here. Letter B. I need you to find the domain. Look at this right here. I need you to factor that. What do you pull out of 2x cubed plus 2x?
2x.
What's left? X squared plus 1. Now, can you factor x squared plus 1? No, thank you. If it said x squared minus 1, then yes, you could. So this is not going to give you anything that you can work with, but this is. X cannot be 0. So your domain is all real numbers except 0. So negative infinity to 0, union 0 to infinity. Or x such that x cannot be 0.
Do we have to know that?
Well,
No.
I want you to do, for me, interval notation, but I don't know if you go to Calc or if you go to in college what they're going to have you do. At Macomb, they have them do, every class is different, but I'm just giving you so you're familiar with everything. I want you to do this, set notation. Now, what's the vertical asymptote for this one? X equals 0. Okay? Now we have another asymptote called the horizontal asymptote. And that's what all this writing talks about. We have other asymptotes. If it's bottom heavy, you know what bottom heavy means? If the degree of the bottom is larger, so let's say, give me an example of a problem where the degree of the bottom is larger than the degree of the top.
X squared minus 4.
Good. Actually, we shouldn't use this one because it says, actually that's fine, that's fine. This one's bottom heavy. If the degree of this is 2 and the degree of this is 1. If it's bottom heavy, we're talking about a horizontal asymptote. It's going to have y equals 0 as a horizontal asymptote. If the degrees of the two, numerator and denominator, are the same, so in other words, 3x squared minus 4 and 2x squared minus 3. If the degrees are the same, you will have y equals the line 3/2, which is 1/2. Do you know where I got 3/2? The leading coefficients. So, if it's bottom heavy, y equals 0. If the degrees are the same, even Steven, it's 3/2. You do the leading coefficient over the leading coefficient. If it's top heavy, there is none. So what's an example of top heavy? Something that is, let's say, x cubed over x to the first power. And who cares about it? Okay, so horizontal asymptote. Horizontal. If it's bottom heavy, y equals 0. If they're the same, you take the leading coefficients. And if it's top heavy, there are none. You write none. Now, if it's top heavy by 1 degree, so for example, if I gave you y equals x cubed plus 4 over x squared minus 1. If it's top heavy by 1, there are no horizontal asymptotes, but there is a slant asymptote. A slant asymptote is a line. Now, if it's top heavy by 1, there's a slant asymptote, and to find it, you have to either do long division or synthetic. How would you do this one? You have to divide this into that. So x squared minus 1 into that. We'll talk about that in a minute. If it's top heavy by 2, like this one, this is top heavy by 2, there's a parabolic asymptote, PA. And a parabolic asymptote looks like a parabola. Parabolic asymptote is a parabola. And again, you have to do division. Now you could do synthetic or long division based on the problem itself. Okay, so we have all these asymptotes we have to look at. So look at this problem, these two problems right here at the bottom of the first page. These are both top heavy. They're both top heavy. So the horizontal asymptote is none. You're going to write none. HA is none. But what do they have? This one has, these both have a slant asymptote. How do I know they have a slant asymptote? Because they're top heavy by exactly 1 degree. Now you have to find the slant asymptote. For this one, you're gonna have to do long division. But this one, you can do synthetic division. How do you do long division on this problem? You remember long division? You would have to do x squared plus 1, and then you have to do 2x cubed plus 0x squared, and then minus x plus 4. Now you don't need the remainder. You can stop with the remainder. So what you're going to get a parabola, or I'm sorry, you're going to get a line here because it's a slant. So 2x squared times, we got to get a 2x here. So what do we need? We need an x and a 2. 2x. 2x times x squared is 2x to the third, and then 2x times 1 is 2x. And now we're going to subtract these two. And you get negative 2x, and then bring down negative x. And now what do we need here? And that's actually going to be it. You're done. Actually, this is a squared. 2x times x is 2x cubed.
Would you still need the placeholder for the x squared plus 1?
Wouldn't it be minus 3x?
Yes. I have like no room here. X squared plus 0x plus 1. 2x cubed plus 0x squared minus x plus 4. Let me do this right. Okay, so let's do it right. So we need 2x, right? And it's going to be a line. It's going to be linear because it's 1 degree higher on top. So 2x times this is 2x cubed. This times this is 0x squared. And this times this is 2x. Right? Subtract. These are gone. This is nothing. And this is going to be negative 3x. And now bring down the 4. And now we don't, that's all you're going to have. That's actually the remainder. This is a weird problem. So y equals 2x is your slant asymptote. Okay, so how would you graph that? You would begin here at 0 and you'd go up 2 and over 1. And you just graph it like that. Y equals 2x.
You don't do anything with the remainder?
No, you don't need the remainder. You do not need the remainder. Now on this one right here, how do you find the asymptote there? That is going to have a slant asymptote as well, but you can do synthetic division on this one because it has a degree of 1. You would put a negative 1 outside, and then a 1, a negative 1, and a 4. Bring down the 1, multiply, add, multiply, and I don't need this remainder. So this slant asymptote has the equation y equals 1x minus 2. That's your slant asymptote. Okay, next, flip to the back. Now these two are top heavy, so they don't have horizontal asymptotes, but they're top heavy by 2, so they have parabolic asymptotes. Again, how do you find the parabola? You have to do, this one you're going to have to do long division, and you're going to have an equation that is like y equals x squared. This one you can do synthetic division. Let's do this one. This one you're going to put a negative 1 outside, and you have 2, 0, negative 1, and 4. Let me shorten this line. So bring down the 2, multiply, add, and you are done because you don't need the remainder. So your equation is y equals 2x squared minus 2x plus 1. You'll have to graph that. It's a parabola. Let me make sure I did it right. You put your negative 1 outside. Your 2, your 0, your negative 1, and your 4. Bring down the 2. Multiply, add, and you don't need the remainder. So 2x squared minus 2x plus 1 is your parabola. Now for this one, you'd have to do long division because you can't do synthetic. You know you can't do synthetic because of that too. Now let's run through these and talk about what kind of asymptote it has. These are just examples. See these two right here? These degrees are what? The same. So what kind of asymptote does it have? Horizontal. What is the name of the horizontal asymptote? Y equals 5 over 2. Is there another name for 5 over 2? Yes, 2.5. How about the next one? It's top heavy by 2. So it has a parabolic asymptote. How do you find it? I would do synthetic division, put a 1 out here, a 1, a 0, a 2, and a negative 1. 1 times 1 is 1, add 1, add, and I don't care about the remainder. So what's your parabolic asymptote? It's y equals x squared plus 1x plus 3. You're going to have to graph that parabola. What kind of asymptote does this have? Again, it's top heavy by 1, but this one has a slant, an SA, slant. You're going to put negative 1 outside. 1, 3, negative 5, bring down the 1, negative 1, add, multiply, and we really don't care about this anyway, so it's y equals 1x plus 2. That's your slant. It's a line. And what's this one? This is bottom heavy. Y equals 0. Good job. Okay, now 2 more things you need to know. How do you find the y-intercept of anything? You set x equal to 0 and you solve for y. So look at this one example right here. If I asked you what is the y-intercept, all you're doing is crossing these x's out, plugging 0 in for x. And if x were 0 here, what would y be? What's negative 1 over negative 1? 1. So 0, 1 would be your y-intercept. How about this one? If x were 0, 0, 0, 0, you'd have 0, comma, negative 5. What about this one? If x were 0, 0 cubed, 0 cubed, 0 to the 4th, you'd have 0, negative 4 sevenths. Okay, everyone can find the y-intercept, right? And the last thing is a hole. If this happens, where you factor your rational function, so this one, you got x squared minus 4. So they factor x minus 2, x plus 2. Now normally you have an asymptote at x equals 2, right? But if I cancel those out, what happened to the x equals 2? It's gone. This is a hole. You will have a hole at 2, comma, you're going to plug this 2 in what's left, 2, comma 4. So when you go to graph your function at 2, 4, instead of having an asymptote at 2, because you would normally have an asymptote at 2, at 2, 4, you're going to put a hole there. Okay, so let's do another one. Let's say I had x minus 3, x plus 1 over x. Let's say I did this. Where's my hole? 3, comma 4. Okay, that's a hole. It only happens when you lose a factor completely. Okay? All right, now, let's do an example. Example 1. Now, see where it says CV? I want you to put CV on top. I accidentally typed it wrong next to roots. CV stands for critical value. You will have a critical value anywhere you have a variable in the numerator or the denominator. You're going to have a critical value. A critical value is where a change is going to occur. So every variable has something's going to occur. So right here, that's a critical value at x equals 0. Set each variable equal to 0. Now this right here, we're going to have to break this up. How do you break up x squared minus 3x minus 4? Mm-hmm. We have two more critical values, at 4 and at -1. So things are going to happen at 0. They're going to happen at 4 and at -1. 0, 4, and -1. We're going to use these three numbers to create an exclusion chart. You guys remember doing these last year? Okay, I want you to order these numbers left to right. -1 comes first, then 0, then 4. And along vertically, I want you to name each of these products. So x, then x minus 1, and it doesn't matter what order you put them in. X minus 1, or x plus 1, sorry, bless you. And f, and the grand finale is the f of x. That's the end. So I need you, the critical values have to be split up so that you have space before each one, in between, and after. Does that make sense? So now, find the 0 at each critical value. Now think of a number line. So here's 0. Find your critical, to the left of 0, all those numbers are negative, and to the right are positive, right? So you're going to draw pluses and minuses. So at x, at 0, right here, here's your 0. These are going to be, these numbers will all be negative, and these numbers will all be positive. So if I randomly selected a number in this region, it would be negative, negative, positive, positive. So check out x minus 4. Where is the 0 associated with? If I set this equal to 0, it's right here, right? So to the left of this number, these are all negatives, and this is a positive, right? How about the x plus 1? Where's the negative? Right here. So that's a negative, and these are all positives. So now, what I need you to do is count. If we count an odd number of negatives, it's going to be negative. So that's an odd number, 1, 2, 3, odd, even, odd. Now, they're not always going to alternate like that, but I think 95% of the time they do alternate. What does this negative, see if anyone remembers what the positive and negative means. What does positive and negative mean?
It's before -1, it's below the x-axis. If it's between -1 and 0, it's above the x-axis. And then between 0 and 4, it's below the x-axis, and it's after 4, it's above it.
You got it. This is where your graph is. This is going to tell you where your graph's at. So negative means below the x-axis. Between -1 and 0, it's going to be above, below, and above. So now, let's fill in this. What are the roots? The roots are only where the numerator is set equal to 0. Sometimes you won't have a variable in the numerator, but we do here. So we have one actual x-intercept, and it's at 0. I want you to put a 0, a dot at x equals 0 right here. Okay, now, what are my vertical asymptotes? So I want you to graph them. X equals 4 and x equals -1. X equals 4, and they're going to be broken dotted lines. Now, vertical asymptotes are very strong. Graphs cannot cross them. Horizontal asymptotes are weak. They're weak around the origin. A graph can cross a horizontal, but it's more for the end behavior, okay? Horizontals are weak, verticals are very strong, okay? Just want you to remember that. Now, your graph will have one of these. It can't be bottom heavy. Horizontal means bottom heavy. Slant and parabolic mean top heavy. So you're only going to have one of these. It can't be bottom heavy and top heavy. So don't be giving me both of these. Decide, is this a bottom heavy or a top heavy?
Bottom.
It's bottom heavy, right? So if it's bottom heavy, it's not top heavy. Cross those out. So it's bottom heavy. So what, it's bottom heavy, so y equals 0. So I want you to draw a broken line on the on the x-axis, like that. Now, the y-intercept, everyone can do that. Plug a 0 in here, a 0 in here, a 0 in here. You get 0 over -4. We already know what the y-intercept is, because it's already graphed. 0, 0. There can only be one y-intercept. 0, 0. Is 0 whole? No, we didn't cross anything out. Now we get to do the fun part. Doing what Matt said. We're going to use our asymptotes are hints where the graph is. So, here we go. -1, where's -1? That's our first critical value. It's saying we are in the negative region. So we are in the negative region. What some people will do is they will cross this out. So you're not in this region. Some people will do that. You don't have to. So where, you've got two asymptotes, here and here. So just draw something like that. Reminds me of a boomerang. No. Nope. Okay, now we're between -1 and 0. Here's -1 and here's 0. We're in the positive region, so we're not down here. We're not in this region. We're in the positive region. We're up here. Now, even though there's an asymptote here, it's a weak one. We can cross it right around here. We can. Now, between 0 and 4, it says negative. We're in this region. So we're not here. We're not in this region up here. So we're in this region. And between 4 and infinity, we're in the positive region. So I'm going to just follow my asymptote. And that's it. Let's do another one, number 2. Factor the numerator. Tell me what you get when you factor it. X minus 2, x plus 1 over x minus 1. What are my critical values?
2, -1.
2, -1, and 1. So I do my exclusion chart first. Do that to get it over with. So I have put a -1 and then a 1. You want to make sure that these numbers are in order. If not, your graph will be messed up. And then put your factors. So we've got, and these don't have to be x minus, they don't have to be in order. X plus, because you're just counting them. X plus 1, x minus 1, and f of x. Okay, so, see if you guys understand. Do you guys understand this exclusion chart?
Yeah.
Okay, so tell me what to do. Okay, I find my 0. So x minus 2, here's the 0 right here. So these are negatives, and that's positive. This one's going to be the opposite. It's the opposite, so it's negative, it's positive. This one's positive 1, negative. So do my counting now. I got 3 on my first column, so it's negative, and positive, negative, and positive. Okay, what are the roots? 2 and -1. What do I do with 2 and -1? 2 and -1. Do I do anything with them? I put dots on my x-axis. 2, those are part of the graphs. 2 and -1. What's the vertical asymptote? X equals 1. Graph. X equals 1. Broken line. Okay, what kind of asymptote? We have a slant. Why? It's not bottom heavy, and it's top heavy by 1. How do you find that slant? I'm gonna do synthetic too. So I'm gonna put a 1 out. One, -1, and -2. Bring down the 1. 1 times 1 is 1, and when we add, we get 0. Y equals x, you got it. Y equals x. That is just this line right here. It's broken. Is there a hole? What's the y-intercept? 0, 2. Put a dot at 0, 2. Okay, now, what does this graph look like? From negative infinity to -1, according to our exclusion chart, it's in the negative region. Now, I've got this broken line here. Should I draw something here? This is where you gotta use your common sense. These 2 points are part of my graph. Made them nice and solid. So I need to go in this negative region, but I want to be able to, because I don't want to cross this imaginary line. So I'm still in the negative region, but I'm going to pick that up. So between from negative infinity to -1, this says I'm in the negative. So I'm still in the negative, but I'm going to be able to pick up my buddy -1. Then from -1 to 1, here's from -1 to 1, I need to be in the positive region. I got to pick up this dude right here and carry on up to the asymptote. From 1 to 2, I'm in the negative region. So this would be my small negative region. Go up here and pause from 2 to infinity. Here's 2 to infinity. And I'm done. Questions? Let's do one more.
Please excuse this interruption. Attention all participants of the Live Mas Spanish video. Please remember to report to room 200 during the tutorial time tomorrow for your special surprise. And those of you who participated in the Taco Bell survey, your coupon must be redeemed today. Also, Science Olympiad is canceled for tonight. Thank you.
You know, we're gonna do this one tomorrow. I want to do it easier. We'll stop. All right, we'll stop. Okay, now I just want to say something. That second sheet of paper is your homework.
Should we stop?
We're gonna stop. You can stop the video, but actually that's okay. It's okay. Just let it go.
Run it.
This is your homework right here. This packet needs to be done. What you could do, this is a suggestion, is possibly go through and maybe do all the critical values, all the roots, maybe do the chart. Do all the asymptotes. Do all the y-intercepts. Do all the holes. Because there's a lot here. And, you know, I don't want you to wait till the last minute to do them all. Okay? So pace yourself. You got a test on Thursday. So do a little bit tonight. And then a little bit tomorrow and the next day.